3.8, start on page 10 of your packet. So if you look at question 1, it says consider the function f of x equals 1/2 times x plus 2 squared plus 8. So first of all, this plus 8 right here, I apologize, you guys, this should be minus 8 and not plus 8. So if you could correct that typo for me, that would be awesome. Sorry about that. So if you notice right here, this is already written in vertex form. The equation that we have here is written in vertex form. So therefore, I can look at my equation and I can see that my vertex is going to be -2, -8. So let's fill this in right here. My vertex is -2, -8. And the axis of symmetry always occurs on my vertex. So the axis of symmetry is going to be x equals -2. Okay, now looking at my a value, I can see that the a value is positive. So that means that my graph opens up right here. So this is going to be a minimum. And then my y-intercept will happen when x equals 0. Okay, so I'm going to figure out what f of 0 is going to be. So I'm going to do f of 0 equals 1/2, plug in 0 for x, so 1/2 times 0 plus 2 squared minus 8. So I get f of 0 equals 1/2. 0 plus 2 is 2, so I get 1/2 of 2 squared minus 8. So then I end up getting f of 0 equals 1/2 times 4 minus 8. So I get f of 0 equals 2 minus 8, which is -6. So my y-intercept will be 0, -6. Okay, now to find my roots happen when y equals 0. So every time I see a y, or here f of x, I'm going to replace it with 0. So I'm going to say 0 equals 1/2 times x plus 2 quantity squared minus 8. Now, in order to solve for x, I'm going to get rid of this minus 8 first. So I'm going to add 8 to both sides. So I get 8 equals 1/2 times x plus 2 quantity squared. Okay, then I'm going to multiply both sides by 2, because when I multiply by 2 here, these 2's cancel out. So I end up getting 16 equals x plus 2 quantity squared. Now, don't forget that if I want to square something, to get rid of it, I'm going to square root both sides. So the square root of 16 is 4. So I'm going to have plus or minus 4 is equal to x plus 2. So to solve for x, I'm going to subtract 2 from both sides. So I end up getting -2 plus or minus 4 is what x is equal to. So therefore, I could say x equals -2 plus 4, or just 2. And I can also say that x equals -2 minus 4, which is -6. So therefore, my roots are going to be -6 and +2. Okay, and then we're going to figure out the domain and the range after we do part B, which says to use the information to graph f of x. So if you could open up your packet, so pages 10 and 11 are both open next to each other. We're going to go ahead and figure out how to graph this out. So the first thing I'm going to do is label my axes here. So I'm going to label this the x-axis and label this the y, and then I'm just going to go ahead and number my axes. So to save time and space, I'm just going to go by 5s. So we'll have -5 here, and then we'll have -5 here, and -10 down here. So I know that my axis of symmetry is going to occur at x equals -2. So I'm going to draw out x equals -2. I'm going to go to x equals -2, and I'm going to draw a vertical line right down here, okay? And then I also know that my vertex is going to happen at -2, -8. So I'm going to go to -2, -8, and I'm going to put a dot there because I know that's going to be one of my points. I also know that 0, -6 is going to be my y-intercept right here. And because this is 2 to the right of my axis of symmetry, I also know that 2 to the left of my axis of symmetry will also have a corresponding y value of -6 because it's symmetrical. Okay, I also know that my roots are going to occur at -6. So right here, I have a root at -6, and I also have a root at 2. Okay, so based on all that information, this is what my parabola should look like. This is how I'm going to graph out my parabola. And don't forget to write f of x is equal to 1/2 times x plus 2 squared minus 8. Okay, so now that I've done that, I'm going to find the equation for the inverse of f of x. So to find the inverse of f of x, if the equation is y equals 1/2 times x plus 2 squared minus 8, I'm going to take x and y and I'm going to swap them. So I'm going to say x equals 1/2, and then instead of x right here, I'm going to use y. So I'll have y plus 2 squared minus 8. And remember, our goal is to get that y alone. So I'm going to add 8 to both sides. So right here, I end up getting x plus 8 equals 1/2 times y plus 2 squared. Okay? Then I'm going to multiply both sides by 2 to cancel out this 2 right here. So I end up getting 2 bracket x plus 8 is equal to y plus 2 squared. Okay, now to get rid of my square, I have to square root both sides. So I end up getting 2x plus 8 all under a radical, and it has to be plus or minus because when you square root a value, you could get positive or negative. So we end up getting plus or minus root 2, x plus 8 equals y plus 2. Now I'm going to subtract 2 from both sides, so I end up getting negative 2 plus or minus 2 times x plus 8 under the radical, and that's what y is. So therefore, my inverse function is going to be negative 2 plus or minus the square root of 2 times x plus 8. Okay? So now, part D says to graph the inverse function on the same set of axes. And I can use the rules for transformations of functions. I can see, oh, it's going to be the square root function with a compression of 1/2, because this is 2 when we do the reciprocal, that went to the left 8 and down 2. But all I have to do is take this function right here, which I already have points for, and remember, if you're going to swap the x for the y, you can do the exact same thing for your coordinates right here. So for example, if this coordinate down here is negative 2, negative 8, I can swap it, and I would have negative 8, negative 2. So all I'm doing is swapping the vertices. So if my vertex is negative 2, negative 8, then my new point would be negative 8, negative 2. Okay? If my y-intercept was 0, negative 6, then my new coordinate would be negative 6, 0. So I know I'm going to have a y-intercept, or my new coordinate is going to be here at negative 6, 0. So let me actually put it in a different color so we can kind of see it. So here's negative 2, negative 8, negative 2. Here's negative 6, 0. We also had this point right here, which was negative 4, negative 6. So when I swap it, I'm going to have negative 6, negative 4. So here is another point that I have here. We also have our roots are at 2, 0. So if this is 2, 0, then when I switch it, I would go to 0, 2. Okay, and if this point right here was negative 6, 0, then I would switch it and I would go to 0, negative 6. So then once I've done that, I can see right here that this is going to be what my inverse function ends up looking. So this is f inverse of x. Okay? If you notice right here, it normally would start at 0, 0, but this time it went to the left 8 because this says go to the left 8, and it also went down 2. So that's what ended up happening here. And then it's compressed right here with a scale factor of 1/2, but it's the positive side and the negative side because it says plus or minus right here. Okay, so the domain of my of my f inverse function right here, we're going to talk about it after we talk about the domain of the original function. I'm sorry, I forgot to talk about that. So the domain of the original function, because it's quadratic, this red function right here will go on forever, everywhere, from left to right. So my domain is going to be x is an element of the reals. Okay, but for my range, we can see that it has a lowest point right here. So for my range, we're going to say y is an element of the reals such that y is greater than or equal to negative 8. Okay, so now the domain of our inverse function right here, we can see that it has a lowest point. It doesn't go past negative 8. So therefore, my domain is going to be x is an element of the reals such that x is greater than or equal to negative 8. Okay, and then for my range, if you notice right here, this goes on forever vertically down this way, and over here, this will go on forever up here. So therefore, my range is going to be y is an element of the reals. Notice how the domain and the range of the original function swapped with the domain and the range of the inverse function, which should make sense because x and y should always be opposites of each other. So is f inverse of x a function? If I were to do the vertical line test, even using this axis of symmetry right here, I can use that as my vertical line. It intersects more than once. So we can say f inverse of x is not a function because it doesn't pass the vertical line test. Okay? All right, number 2 asks us to determine the equation of the quadratic function that has a vertex of 3, 7 and has a y-intercept of 0, -5. Because it has a vertex of 3, 7, then most likely my best bet is to use the vertex form equation. So f of x is equal to a times x minus h squared plus k. So here I'm going to say f of x is equal to, I don't know the a value here, so we're going to keep it as a times x, and then here we're going to do minus 3. So x minus 3 squared plus k is going to be 7. Okay, now we also know that it has a y-intercept of 0, -5. So what I want to do is I just want to draw a quick sketch of it to see, predict if my a value is going to be positive or negative. So if it has a vertex of 3, 7, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 right here, this right here is what my vertex is, and the y-intercept is 0, -5. So this right here is going to be a point, and then we know that this is our vertex right here. Well, our vertex is either our minimum or our maximum, and since our y-intercept is lower than our vertex, then our vertex, has to be a maximum. So right here, we know our graph is going to look something like this. Therefore, our a value should end up being negative, okay? But I'm going to leave it as a right here. Well, if it goes through the point 0, -5, I know that x is 0 and y is -5. That's one example of what x and y could be. So I'm going to replace f of x with -5, and I'm going to say -5 equals a. I'm also going to replace the x with 0. So a times 0 minus 3 squared plus 7. So I end up getting -5 equals a times -3 squared plus 7. So I get -5 equals -3 squared is -3 times -3 or positive 9. 9a plus 7. I'm going to subtract 7 from both sides, so I get -12 equals 9a. Divide both sides by 9, and I end up getting that a equals -12/9, but when I reduce it, I get -4/3. So our a value here is negative, just like we wanted it to be. So therefore, my equation would be f of x equals -4/3 times x minus 3 squared plus 7. Okay, and I want to verify this using Desmos. So if you notice, I typed in f of x equals -4/3 x minus 3 squared plus 7. Obviously, it does have that vertex of 3, 7, just like we want. But I want to look at my y-intercept, and here, if you look at my y-intercept, it's 0, -5, which is exactly what I want, so my equation is correct. Okay, so now in question number 3, it says determine the equation of a quadratic function that passes through -320 if its zeros are 2 and -1. So this time, in order to be able to do a question like this, I know the zeros, I'm going to use factored form. So f of x equals a times x minus r times x minus s. But same thing, I want to draw a sketch of it to see what it's going to look like. So if the zeros are 2, and -1, here are where my zeros are going to be. But I also know that it passes through the point -3, positive 20 up here. So that means that it's going to pass through this point right here. So the graph has to go down and try to get it to actually go through your root right here. And this is what your graph should end up looking like. So that means that a is going to have to be positive. So when I plug in my value right here, I know x is -3 and that y is 20. So here, before we actually plug in these values, I need to first write out what my equation is going to be with the a left as a. So I'm going to say a, and then here I know my first root is 2, so it would be x minus 2. And here I know my second root is -1, so it would be x minus -1, or just x plus 1. All right, so now I can plug in my numbers here. So I'm going to plug in 20 for y. So I'm going to say 20 is equal to a, and then instead of x, I'm going to replace it with a -3. So I'll have -3 minus 2. And then here again, instead of x, I'm going to replace it with -3, and then I'll have plus 1. So then I'm going to use order of operations to evaluate what I have here. So I'm going to leave this as 20 equals a, and then -3 minus 2 is -5, and -3 plus 1 is -2. So I get 20 equals -5 times -2 is 10, so 10a. Divide both sides by 10, I get 2 equals a. So therefore, my equation is going to be f of x equals 2 times x minus 2 times x plus 1. Okay, and we can multiply it all out if you want to, but this is an acceptable form as well. So let's go ahead and go back to Desmos, and we're going to write our equation in right here. So we're going to say 2 times bracket x minus 2 times x plus 1. And when I look at my graph right here, I can see that I have the points -1, 0, and 2, 0. Those are my roots. But I'm more interested to see if it's really going to go through the point -3, 20. So I'm going to go up here, and I'm going to go to -3, and I'm going to go all the way up to 20 and see if that's going to be an actual point. So if I were to go onto it right here, it looks like -3, 20 is a possibility. And then another option that I have right here is to actually figure out what f of 20 is, or f of -3 is. And it tells me that the value is 20 right here. Okay, so that's going to be my equation right here, and we should be good to go for this question. Let me know if you have any other questions, and I will see you soon. Have a great day.